So we're recording, everybody, and here we go. Let's go through a quick review of what we did yesterday, talking about the inverse functions. I'm going to treat this as a series of questions, essentially, like math problems. So we're going to tackle the different things we might see through the lens of problem solving. So here's our first one. Determine the inverse relation for each set of ordered pairs. This is like the homework question you did for number 1, but I'm going to show you part B, which is the one you did not do for homework. Graph each relation and its inverse. Okay, so we're using the graph here. I'm going to have to get my pen out. First, let's do my first one in blue. And I don't really have room over here, so well, maybe I'll just cross this out and I'll write f of x. So we're going to label this as our regular function. Okay, and I'm going to use blue to graph it on the graph here. So we got 2 and 5, 1, 2, 3, 4, 5, so we got one right here. Let's make that pen a little bit bigger. There we go. So we got one right there. Our next one is 2 and -1, so that's going to be right here. Then we've got 3 and 1, that's right here. And then we got 5 and 1. That's right here. Okay, so those are my 4 points. I've graphed my f at x. I'm also going to label on here f at x in blue, just so I remember that my blue stuff is that function. Okay, let's do red, and this is going to be our inverse function. So I know whenever I'm doing an inverse function and I've got points or a table of values, all I need to do is switch my x's and my y's. Give me just a minute here, folks. I'm getting some microphone feedback. Can I ask everybody, please, to just unmute and then remute their microphone? We're having that same problem as yesterday. Okay, I think we're good. Thanks, folks. That seems to have taken care of it. Okay, so I've got to do this in opposite fashion, so I'll start with a squiggle bracket. That's not my best work, but I'll take it. And I'm going to put, instead of 2, 5, I'm going to go 5, 2. So I'm switching my x and my y values. Instead of 2, -1, I'll go -1 and 2. Instead of 3 and 1, I'll go 1 and 3. Instead of 5 and 1, I'll go 1 and 5. So I've switched my x and my y values, and so this is going to be my inverse function. Basically, it used to be when I put in a 2, I get a 5 or a -1, and now it's when I put in a 5, I get a 2, or when I put in a -1, I get a 2. So basically, like that input-output cycle, it's doing it in reverse. Okay, so let's graph these. And so I've got 5, 2, 1, 2, 3, 4, 5, 1, 2. So I got one right here. -1 and 2. So I got one right there. 1 and 3. Got one right there. And 1 and 5. One right there. Okay, now right now this just looks kind of like a mess of dots. Let's put my dividing line, my y equals x dividing line on here. And so this is going to make a mirror upon which all of my points should be reflected. So I'm looking at a blue point and a red point, a blue point and a red point, a red point and a blue point, red point and a blue point. It looks like they're all reflected, and so this forms like a mirror, and that tells us we know we've done our inverse correctly. Let's also label our graph here. Red is going to be the inverse. So we know when we see red, we're talking about the inverse. Okay, so that's how we do the inverse when we're given a set of ordered pairs. That's similar to one of the ones you did for homework yesterday. Here's a mapping diagram. I didn't assign one of these for homework, but I did want to go through this. So mapping diagram, similar to a set of ordered pairs, but it's set up a little differently. So here's our mapping diagram. Our first question, is this a function? I'd like you to tell me in the chat, do you think this is a function? Yes or no? So go ahead and tell me in the chat right now. It looks like we're getting some horrible lag today, folks. I don't know what it's like on your end. On my end, it's not great. So for now, folks, if you've got your video on, I'll ask you just to turn it off. I'm going to turn mine off as well. And my hope is that that's going to improve our lag here a little bit. So if you have a video on, I'll ask you to go ahead and just turn it off for now. And we'll hope that that'll improve things a bit. Thanks for letting me know, Emmy. I'm getting some horrible lag on my end, folks. So I'm going to ask you if you've got a video on, if you can just turn it off for now. I'm hoping that'll improve things a little bit. Thanks. Okay, so let's hope that lagginess gets a little better. I hope it's not terrible on your end. Hang in there. You can always watch the video later and that'll be nice and clear. So looking at our mapping diagram, we can say, yeah, it's a function because each x value maps to a single y value. Of course, several of the x values map to the same y value, but they each only map to one, right? For each input, there's only a single output. When you put in -4, you can't get two different answers. When you put in -2, you can't get 2 or 3 or 4 different answers. When you put in 2, you can't get 2 or 3 or 4 different answers. You can only get a single answer. So yes, that's going to be a function. It sure is. Now for what its inverse going to look like, we got a nice little mapping diagram that I've done here. And we can use this mapping diagram to do our inverse. So for our mapping diagram inverse, we're just going to put our y values where x values were and our x values where our y values were. And then we're going to draw how the mapping looks. So 6 goes to 5, and 1 can actually map to any of these three. So is the inverse a function? I'd like you to tell me in the chat right now. And while you're typing in the chat, I'm going to reveal my graph and I'm going to start graphing these. So go ahead and tell me in the chat right now, is the inverse a function? Okay, I'm seeing everybody saying no, it's not a function because, for example, one of our input values could have 3 different output values. So no, it's not a function. Let's see what this looks like when we graph it. We'll be able to do the vertical line test as well, right, to see what it looks like. So let's graph, first of all, f of x. I'll do this one in blue. So we've got -4 and 1. 2, 3, 4, and 1 is right there. We've got -2 and 1. We've got +2 and 1. And we've got 5 and 6. Okay, so there. Those are my points for my first function, f at x. Now I'm going to do the inverse function. So let's do that one in, what did I do last time? Let's match that. Let's do it in red. So we'll label our inverse down here. We'll label it f prime at x. And let's actually draw those points on our diagram. So we've got 1 and -4 right there. We've got 1 and -2. We've got 1 and +2. And then we've got 6 and 5. Right there. Okay, so that's our function and our inverse. Let's put it on that dotted line. To see if it creates a nice little mirror to check our work. And lo and behold, it does. Any red dot we look at has a blue dot mirrored on the opposite side of our y equals x line. Perfect. We can also do our vertical line test. If we get out our vertical line, let's make it a little thinner, and we move our vertical line across, I find that for my starting function, f at x, I can't touch 2 points at once, but for my inverse function, I can actually touch 3 points at once. So this fails the vertical line test, so it's not a function, because I can touch multiple points at once. So that's another way we could describe knowing that it's not a function, because it fails the vertical line test. Okay, here's our third kind. This one is a table of values. So we're using a table of values for this one. We want to find the inverse for this relation below. So this is our life expectancy based on date of birth. Now, life expectancy numbers are one of those ones that's really interesting in mathematics and statistics because they really vary a ton depending on what you choose to include and what you don't. So people often talk about how in the past, oh, life expectancy, you couldn't expect to live past 35 or you couldn't expect to live past 47.3. So much of that, though, depends on where we're talking about in the world. And so in terms of like what kind of access to resources and healthcare do they have, but also in terms of infant mortality. Infant mortality rates used to be enormously higher than they are now in Canada and in many other places in the world, most other places in the world. So if you include those numbers, they skew your data really significantly. So it depends on what you want to include. So there's an old saying about statistics, and I'm not going to be able to get it quite right. Let me know if any of you know it, but there's lies, damned lies, and statistics, I think is how it goes, meaning that you can use statistics to lie if you know how to manipulate them properly. And it's not really lying, but what it is using them deceptively. And so the statistics of life expectancy is actually a really interesting one. But we want to do the inverse. So an inverse with a relation like this, when we know the variables, we're just essentially switching how we would graph them. Which ones would go on the x and which ones would go on the y. So when we're doing a table of values, we're starting with our f of x right here, and we're going to head over to our f prime at x, our inverse. And all we have to do is basically just switch the columns. So this is going to be 47.3, this is going to be 54.1, and so on and so forth. And you might say, well, that's not really changing anything. And well, yeah, you'd be right, but how we graph it can often help us see things differently. So you're right that an inverse function is really essentially just the same information going a different direction. Ooh, not 2020, 2000. Okay. So that's all we do for that one. Nice and easy. We just have to flip our data. If I asked you to graph it, you'd have to put it on a graph. And if I asked you if it's a function, you'd want to look and see if each input has multiple outputs, and you could do the vertical line test if you graphed it for that. So table of values, nice and easy. Okay, here are some similar to ones I assigned for homework. You did not do these ones, you did other ones that I assigned for homework, but I wanted to go through a few of these as a way of review. So we've got our graph. For each graph, we're going to identify points that are in common to the function, its inverse, and which inverse relations are functions. So we need to graph our inverse and then say which ones are in common and which ones aren't. So the easiest way to do that is just to throw our dotted line on there. So we'll get our nice dotted line, and that's going to create our mirror image. And I'll do my inverse in red. So, okay, all I have to do is look at this line and post things on the other side. So the easiest one to do first is this one that's on the line. I can say, okay, when I reflect that, it's already on the line, so the reflection is going to be in the same spot. Now I can look at ones that are close to that. This next one to the left, I can see it is diagonally half a square away from the line. So I can make the mirror image right here. The next one to the left, I can see is diagonally a full square away from the line. So I can do that on the other side. And lo and behold, I'm seeing the pattern, right? It's a straight line up and down, just like this other one is a straight line left to right. So now I can actually go and just plug in these other dots. I got 1, 2, 3, 4, 5, 6, 7 dots on the underneath right side of the line. So I'm going to have 1, 2, 3, 4, 5, 6, 7 above the line like that. So a vertical line, sorry, a horizontal line, the inverse will be a vertical line. So our red is our inverse, our blue is our function, and now we need to say some stuff about it. And also, I mean, if you want to invert points, you can just figure out what the coordinates of the point are and then flip the points. So for example, let's say I wanted to just do this point itself, and I was having trouble figuring out where it would appear on the other side of the line. Just look at the coordinates. The coordinates are 4 and -2. So that means my inverse should have a point at -2, 4. 1, 2, 3, 4. So that would correspond with this one right here. Okay, so you can easily find the inverse points just by flipping the coordinates. Okay, now let's say what we know about this. Common points. I do see a common point. It is right on the line. Anything that appears on that line will always be a common point. And are they functions? Well, do they pass the vertical line test? F at x does. It's a function. The inverse does not. Doesn't pass the vertical line test, so it's not a function. All right, let's look at E over here. These ones can be a little tricky, these lines. So I'm going to show you how I would approach this. If you found doing these for homework went pretty straightforward for you, that's great. If you found them a bit tricky, I hope this will help. So I'm going to do my mirror line. And now there's a few things I'm going to be able to figure out right away. I know right away that anything that touches the line is going to be a common point. So f of x I'll do in blue. F prime of x I'll do in red. There we go. Okay, so I know that this right on the line, now that's not right on the grid, right? It looks like it's close to a grid point. It's not directly on a grid point though. So that one's kind of a little difficult to know what the coordinates are. Looks like maybe 1.2 and 1.2 are the coordinates, something like that. But that's going to be a common point. And now I need to figure out how it's going to go. So the easiest thing to do is to find some points on this blue line that are right on the grid and figure out what the coordinates are. So I'm going to pick, there's a point right here. That's nicely right on the grid. And then there's one right here too. Those are nicely on the grid. There is one down here as well. I could use that one too. So those ones are nicely on the grid and it's easy to see their coordinates. This one, ooh, that's need a thinner pen here. This one has a coordinate of x coordinate of 0, y coordinate of -5. This one has an x coordinate of 1 and a y coordinate of 0. And this one up here has an x coordinate of 2 and a y coordinate of 5. So what I can do is I can take those points and I can very easily just flip their coordinates to find points on the inverse. So 2 and 5 would map to 5 and 2. 1, 2, 3, 4, 5, and 1, 2. So it's right there. 0 and -5 is going to map to -5 and 0. So -1, 2, 3, 4, 5, and 0 is right there. And now I've got 3 points. I could do another point here. 1 and 0 maps to 0 and 1. That's right here. And so now what I need to do is draw a line through those points. So here we go. So that's going to be my inverse function. Really, I would just need 2 points because all you need is 2 points to draw a line. But I got 4, so that gives me a little bit extra, which is fine. But 2 points would have done it. So that's my inverse. Nicely graphed. Okay, so that's what I recommend you do. Don't try and figure everything out about the line. Just pick a couple of points and then flip the coordinates, and that's going to very easily tell you what the coordinates are of your inverse. It's a little trickier, of course, with a quadratic. We'll show you one of those a little bit later. So common point is something like 1.2, 1.2. That's kind of like, I'll put a little twiddle there because it's close to that. In this case, both of them are functions because they both pass the vertical line test. So I'm going to say they're both functions because both pass the vertical line test. Okay, 2 more, and then we're going to practice on a kind of a quiz thing. A little practice quiz to help practice your skills, see where you're at. Okay, we got a function, g of t equals 3t minus 2. Cool. I would find it easier to just relate these to x's and y's so we don't get confused. So here's how I would rewrite it if I'm writing it just as x's and y's, my relationship. Let's do that just to make it a little bit easier when we do the inverse. So now let's flip the x and the y. The x is going to be here. The y is going to be here. And now let's solve for y. Let's add 2 to both sides to get rid of that 2. And let's divide both sides by 3. Okay, so that's going to be my inverse function. Now let's remind ourselves what we're actually dealing with. We're not dealing with y, we're calling it g at t. So that's going to be my inverse. And instead of an x, I'm using a t. So that's going to be my inverse function. And I can check it, right? There's a nice little easy way to check it. If I put in, let's say, a 1 up here for my t value, what do I get? So 3 times 1 would be 3 minus 2 would be 1. So when I put in 1, I get 1 out. Let's try it over here. When I put in my y coordinate, which also happens to be 1, 1 plus 2 is 3, divided by 3 is also 1. So that works. And any value I put in for x, when I get a value for y, I should be able to take that y value and put it into my inverse function and get my original x value back again. So these do the opposite, right? They do the opposite. One undoes the other. Okay, so let's actually try subbing these in. So this says my inverse function at 7. So my inverse function is right here at 7. So I'm going to say instead of t plus 2, it's going to be 7 plus 2 over 3. That's going to be 9 over 3. 9 divided by 3 is 3. So my inverse function at 7 is 3. That also means if I put a 3 into my original function, I should get a 7 out, which I do. Okay, my inverse function at 13, so that's going to be 13 plus 2 over 3. That's going to be 15 divided by 3, so that's 5. Finally, g inverse at 13 minus g inverse at 7. Oh, I already worked those out. So g inverse at 13, that's just 5, minus g inverse at 7, that's just 3. I worked those out above. And I say, okay, over 13 minus 7, that's going to be 6. 5 minus 3 is 2. So that's going to equal a third when I simplify that fraction. Okay, so we can sub into inverse functions as well. All right, our last one. Sketch the inverse function for this function right here that I'm circling in purple. So here's what I did. I went on Desmos and I drew two things. The first thing I drew on Desmos is my line that's going to be my mirror line. So I said g at x equals x. That's the same as y equals x, right? That's the purple line here. That's my nice straight line. That's my mirror. The next one I put in was 2 times square root of x plus 2. And so here's what I'm seeing from that. Here's what I know what's going on. If I look at that, I say, okay, my parent function is just the square root function. That's my parent function. But I made some changes to it. By putting a 2 in front, I multiplied all my y values by 2. That stretches it out in a vertical direction. So vertical stretch by a factor of 2. And then I added 2 to it. That moves everything up by 2 in the y direction. Okay? And that's why it actually starts right down here at 2 and not at 0, where it would normally start. Okay, so now I need to do the inverse. So what I'm going to do is I'm going to try and look for important points on here. So I notice this one starts at 2, which is a full diagonal square away from my mirror line. That means I've got a starting point for my inverse function over here that's going to mirror that. That's where I'm going to start. I also notice that I have a dot right here that is 1.5 diagonal squares away from my mirror line. So I can go 1.5 diagonal squares away on the other side. I notice right here I've got one that is 1 square diagonally away. So I can put that in there. I notice it crosses the line right here. So that's going to be another point. And then I notice this one right here is a 1/2 square away. So that should be enough to draw it. So I'm going to erase the dots on my original function. And now I'm just going to sketch my inverse. It doesn't have to be a perfect sketch. We're just going to do our best. So we're starting here. And we're going like this. And we're going through the line. And we're continuing off in this direction. There. So that's kind of our pretty rough, pretty wiggly sketch. But you get the idea. That's my inverse, and that's all I would expect of you. If I'm asking you to sketch something, it doesn't need to be beautiful. Something like that is fine, and would show me that you totally understand what's going on. Okay, so we're going to try the practice quiz on Microsoft Forms to check your understanding. I'm going to stop the video right now, and then we'll begin.